Welcome to Precision Technologies. I am Venkat. This is part 63 of SQL Server video series. In this video, we'll discuss about cursors in SQL Server. Relational database management systems, including SQL Server, are very good at handling data in sets. For example, consider this update statement. Update TBL product sales, set unit price is equal to 50, where product ID is equal to 101. All the rows in TBL product sales table which meet the condition in the where clause will have their unit price updated to 50 as a single set. And SQL Server is very efficient at operating on data in sets. In fact, SQL statements like update, delete, select, etc., they handle data in sets in a very efficient way. But however, if there is ever a need for us to process the rows on a row by row basis, then cursors can be used. Cursors are very bad for performance and they should always be avoided. Since cursors operate on a row by row basis, they can be extremely slow. But remember, most of the time these cursors can be very easily replaced using joins. And in SQL Server there are different types of cursors: forward only, static, key set, dynamic, etc. We'll talk about the differences between these cursor types in a later video session. Let's look at a simple example of using cursors. Now, before we look at cursors, let's understand what a cursor is. A cursor is nothing more than a pointer to a row. Now, let's say when I execute a select statement, I have this result set, and I want to process the rows within this result set on a row by row basis. I want to process individual row at a time. Okay, so if that's the case, I can have a pointer or a cursor pointing to this result set. Maybe the cursor is pointing to the first row, and if I ask it to give the row, it gives me the first row and then it moves to the second row. And then when I ask it to give the row again, it's going to get that row and move to the next row. At some point of time when it passes, when the cursor returns the 10th record, there are no more rows within this result set, in which case it doesn't return anything back. Okay, so let's see how to use cursors. Now what I basically want to do is, using cursors, I want to print the ID and the name of each row that is present in TBL products table. Okay, so I have two variables to hold the ID and the name. Product ID is of type integer, name is of type nvarchar. And then look at this. This is the statement where we are declaring a cursor using the declare keyword. Declare name of the cursor and then cursor for. Okay, we will have a cursor for a result set, and to get the result set we use a select query. So if I execute the select query, I'm going to get all the products where ID is less than or equal to 1000. Just to make this query run a little faster, I have only retrieved 1000 records, otherwise it's going to take a little bit of time. Okay, so this select statement is giving me a result set, and I am asking a pointer or a cursor to be pointing to that result set. Okay, so declare name of the cursor, cursor for, and you specify a select statement. Okay, so we have declared a cursor at this point. Okay, now when you say open product cursor, which is nothing but this cursor that we have just declared, what's going to happen? The select statement will be executed, and all the rows that match that select statement, the conditions in the where clause, are now retrieved into this result set. And you will have your cursor pointing just above the first record. So the cursor will not be pointing to any row. Okay, it will be pointing, it will be ready to retrieve the rows. Okay, now when you say fetch next from product cursor into product ID and name, what's going to happen? The cursor will retrieve the first record, the ID, into product ID column and the name into the name column, name variable. So we have the data of the first row retrieved into these variables. And then look at this, we are checking, okay, while at fetch status is equal to 0. Now this variable is going to return 0 as long as we have rows within the result set. Okay, remember the cursor will return one row at a time. So it returns the first row, then it goes to the second row, then the third row, etc. Now when it has passed all the 1000 rows, then this at fetch status will not be 0. That's the indication for that, for us to know that we have processed all the rows. So this fetch status will return 0 as long as there are rows to be processed. And now what I want to do, I want to print the ID. So print, let's say ID is equal to whatever ID we get So where is the ID present? ID is present in the set product ID variable. So I'm going to cast that to be of type nvarchar because we are printing the product ID and we are concatenating that to string. So we need to typecast that, and I'm going to say the length as 10. Okay, and then maybe I want to say maybe name is equal to, and where is name present? That's present in this at name variable. And look at this. So we are printing the ID and name, and what do we have again here? Fetch next from product cursor into that variable. So we have got the first row here. Now we are retrieving the second row, and we are going to do this as long as there are rows within our result set, because we are present, these statements are present inside a loop. Okay, now when the cursor reaches the 1000 record, there are no more rows, so the at fetch status will return non-zero, and that's the indication for us we have completed processing the rows in the result set. And then finally I have close product cursor. So what is this going to do? It's going to release the result set. This statement is going to release the result set. And finally deallocate will actually deallocate the resources that are being used by this cursor. Okay, these two statements are very important to close the result set and to deallocate the resources that are used by the cursor. Now let's go ahead and run this and see what's going to happen. So as expected, it should print the ID and the name of the product. So see how easy it is to actually loop through the rows using cursors. Now let's look at a simple example of using cursors. Now let's say, for example, I want to, if you look at this TBL product sales table, it has got the product ID and the unit price, quantity, etc. Now let's say I want to update this unit price, and there are some conditions to follow to update the unit price in TBL product sales table. Now if the product name is product 55, then I want to set the unit price in this table to 55. But whereas if the product name is 65, then I want to set the unit price to 65. But whereas if the product name starts with product dash 100, after that I don't care what we have. But in that case, if a product name is like that, product dash 100 and then anything after that, then I want to set the unit price to 1000. Okay, so I mean these are some crazy conditions, but I want to demonstrate the use of cursors here. Let's see how to do that. And one important thing to keep in mind is we don't have product name in this table. But remember, if the product name is 55, then I want to set the unit price to 55. If the product name is 65, then I want to set the unit price to 65. Whereas if the product name is like, if it starts with product dash 100, then I want to set the unit price to 1000. Okay, there are some conditions, and we don't have product name in this TBL product sales table. So what we will have to do, we'll create a cursor for this table. Okay, for this result set, for all the rows within TBL product sales, and then we will loop through each row, retrieve the product ID, go to the products table, and then retrieve the name, check if the name is 65, 55, then update the unit price to 55, otherwise 65, otherwise 1000. Okay, let's see how to do that. Okay, so I'm going to call that product cursor. I don't need I need a name variable, but I don't need the name here. So I want to retrieve select ID from, not ID, it's actually product ID, because in TBL products sales table, look at this, in TBL product sales we want to retrieve the product ID. So select product ID from TBL product sales table. Okay, and I'm going to get rid of this where clause there, and I want to retrieve, when I retrieve this result set, I'm creating a cursor. Open product cursor and fetch next from product cursor into product ID. There is no name within the result set, so I just have the product ID. So once I have the product ID, then what we want to do, we basically want to retrieve the name of the product. Look at this, it's the same code. We are declaring two variables. We are declaring a cursor, and we are retrieving the product ID from product sales table, and we are opening the product cursor. We are retrieving the first row into that variable, the product ID into the first the product ID of the first row into this variable. and while fetch status is 0, what do we want to do? We want to retrieve the name of the product. So I'm going to copy this piece of code and paste it there. Okay, so what are we doing here? We already have a variable for the product name, so I'm going to get rid of that, and I'm going to call, instead of simply name, I'm going to call this product name. Okay, so we are retrieving the product name from TBL products table using the ID that we have got into this variable. Okay, and then what we are doing, we are checking if the name is product 55, then we are updating TBL product sales table to set the unit price to 55, where product ID is equal to whatever is the product ID that we have retrieved from TBL product sales table. And the most important thing is now, and we are doing that for product 65 as well. If it's 65, then we are setting the unit price to 65, whereas if the name starts with product dash 100, we are setting the unit price to 1000. And finally, I want to retrieve the next row. I just deleted this by mistake. So fetch next from product cursor into product ID. And this will be repeated as long as we have rows in TBL product sales table. Okay, so let's go ahead and run this and see how long is this going to take. And remember, there are around 600,000 records in my table. So it's processing. Look at that, it's still executing the query. It's going to take a little bit of time, because how is this query executed now? It's going to go to the product sales table. Look at this, it's still executing. It's already 14 seconds and still executing. Let's understand how this query is being executed. Go to the product sales table, retrieve the product ID, and then go to the TBL products table, get the name, and then compare that with 55. If it is 55, then it updates the unit price to 55, otherwise 65, otherwise whatever, 1000. So this is going to do all this processing 600,000 times, because there are 600,000 records in TBL product sales table. And the query has just completed now. Look at this, it took around 43 seconds. Since it has to process the rows on a row by row basis, it took around 43 seconds. But we can very easily replace this cursor's query using joins, and we'll discuss about how to do that in our next video session. And when you replace cursors using joins, it's going to improve the performance significantly. You don't even you will be surprised that the update query, the equivalent update query, is just going to take less than a second if you use joins. Okay, so let's actually see if the update has worked as expected. And to do that, I already have a select query here. So I'm selecting the name and unit price by joining TBL products and TBL product sales, and I have set name is equal to, in the where clause, name is equal to product 55, product 65, or 1000. So obviously when we execute this select query, we should see, look at that, any product that has 100, that the name that starts with product dash 100, the unit price is 1000. If you want to see for product 55 and 65, I'm just going to execute that query, and look at that, product 55, the unit price is 55, and for product 65 it is 65. Okay, so the cursor will loop through each row in TBL product sales table, as there are 600,000 rows to be processed on a row by row basis. It took around 43 seconds on my machine, but we can achieve this very easily using a join, and this will significantly increase the performance. We'll discuss about this in our next video session. On this slide, you can find resources for ASP.NET, C#, and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.